talk about autopilot, a little bit of machine learning technology that we're bringing to the market. Okay? All right, why don't we go ahead and begin? I want to introduce Danny Mashburn. Danny's going to be helping with the presentation. He is the principal developer who's been kind of the guy behind all the code that you're going to see, and is going to offer some highlights and some observations about what we've learned thus far. Okay. Small step, but a big leap. Sorry that we kind of plagiarized that, but, you know, a little bit of bravado, hopefully. Anyway, we'll talk again about the market realities. You know, repetition is the source of all knowledge. So we're going to keep pounding away at this point about the need for better solutions. And we'll talk about, kind of focus in on this area. What we've been doing with autopilot initially is focusing on the age-old question of how do I ensure I have the right safety stock or red zone values? How do I ensure that I have the proper amount of cushion there to address my item variation and other factors? And this has been a problem since the beginning of supply chain, and we think we've made a huge step forward on that. Then we'll talk about the vision, what we're trying to do with the autopilot in its first incarnation. We have made massive progress on this in the past year. We'll actually, you know, we were looking at some of the screenshots of the prototype we were working with a year ago when we shared it at our user conference, and I think you'll see that it's advanced quite a bit from there. We'll do a bit of a demonstration and we'll talk about our next steps. We're going to ask for your feedback. So we're going to try out this WhoopClap application here in a few minutes to get your feedback on this. Well, then after the autopilot session, we're going to take another short break and then we'll start back into the rest of the content. We want to make sure you stay fresh, have a chance to catch up on emails and things like that, and keep the agenda moving as well. Okay, anybody want to pitch this chart for me? Do you understand what I'm saying here? You know, inventory turns have not improved. How the hell can that be the case with all this money that we've spent? We've got this complex software. You know, the Apollo astronauts, the best of the best of the best, were the only ones who got to go on those missions. That seems like what the way our software solutions are today. That's a call to action that we should be able to improve on that. We started seeing through our simulations that we were doing for each and every prospective client, primarily around DDMRP, that certain things started emerging out of that analysis. So what we would do is we would get your historical demand for your items, your item master data. We would put that initially into an Excel, it was an Excel workbook that would simulate a day-by-day progression of what the inventory management would have been with DDMRP buffering for your items. And from that, we could establish what the service levels would have been. In other words, how many days stocked out would you have? We could also determine what your average inventory levels were. More importantly than anything, we would find the outliers. What happened with this part? Demand, 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 everything looks great. Then all of a sudden there's no demand, then there's this huge amount of demand, then there's demand, demand, demand. What was going on there? Oh, that was on back order. And we couldn't ship it anymore. So we had no demand for 3 months, finally got the part back in stock. We shipped a ton of it out to the forward locations. That was that big pulse of demand. Then it got back into more of a steady state kind of situation. And anecdote after anecdote after anecdote would come out through those discussions about what was the life that our client or prospect was experiencing. And it really started to give us some ideas about maybe there's a way we can help here. You know, so this idea of let's focus in the DDMRP methodology, and I'll show you a couple of screenshots on this. There's kind of a set of concepts that you use in setting your red zone values, kind of not too different than the statistical methods would be. But what we were finding is that items which had the exact same coefficient of variation would need dramatically different settings. How can that be? You know, this has an identical variation, and we'll show you an actual graphic and kind of get into that a little bit. And so that's what really kind of triggered our thinking around this would be a good candidate for AI/ML because it's a well-known, difficult issue. It's everyone's problem, and yet there ought to be a way to do it in a better way. And if we could, along the way, could figure out a better way to detect bad data, because if we simulate bad data, we get bad results, and then you don't trust what the recommendations are. So maybe actually part of what we need to do is have a better data exceptions platform. Because if we can set those items aside because they look weird, then at least we would, like that backorder problem as an example, be able to give you recommendations that made more sense to you and that your users would trust. Because if you're back in this environment and you're overwhelmed by the system, you don't trust what's going on in there. So you turn to Excel, you come up with your own formulas that you know because you wrote them into the worksheet, and that's why you trust them. And we have to obviously fix that part of the problem. So, anybody want to explain these? These are typical safety stuff. You can find hundreds of these online by just using a tool called Google. And they all have very good ideas behind it. You know, this one here is a safety stock formula with uncertainty about demand. This one's uncertainty about the lead time. This one's uncertainty about both, you know. Your typical user does not know how to turn that into an actual formula, right? There are the CPIMs out there who've been down the path. There's this math majors who would know how to do this, but by and large, it's beyond the reach of the typical user, right? And we even put this kind of a feature into the software for Aptiv, of all companies, because they had a proponent who felt that this would be a little more metrics-based way of approaching it in contrast to the DDMRP technique. And we found that it was difficult to work with because anytime the data got a little wonky, you had an outlier in the demand period, the buffer size would jump dramatically, then people start tuning out because they don't trust what's going on in the system. That's not working in the right direction, right? The DDMRP method says you set up your items in lead time ranges, right? Shorter lead times will have a bigger red zone base because a day lost in a 7-day lead time is a lot more significant than a day lost in a 90-day lead time, right? That's the theory behind it. And you would set up these settings. What's your base percentage there? So I'm out on my first implementation. Eric, how do you know it should be 80% for the 7 to 14-day lead time? I'm looking at my shoes, I'm looking at soul searching for an answer. Well, you know, it's in the book. We'd run a simulation. We knew kind of what it was going to do, but you don't feel like you got the kind of credibility you want to have when your client is asking you that question, right? And the same applied to the variation ranges. Okay, because we're going to add a safety percentage on top of the base. So it says if the COV is less than 50%, add 25%. How do you know it should be 25? Well, again, you know, we blah, blah, blah. That doesn't feel like something I'm going to have a lot of faith in. But despite that, not only did our clients, but hundreds of other companies that implemented DDMRP over the last several years get better results. It worked. We're getting a better way to manage by getting clusters of items based on their lead time range and their variation range. We're getting better results. We are doing our simulations, and we would tweak these numbers. Solar knows how to do this quite well, up and down to fit the various paradigms, and clients got good results. But we also knew that something else was going on, because we would see simulation after simulation that items with the same lead time or the same COV percentage would have dramatically different recommendations, right? So here, all three of these items have a coefficient of variation of 130%, 1.3. They all need dramatically different red zone factors, or what's the safety zone. 23% of usage over the lead time at the bottom. That's this thin little red zone line. 94% in the middle case. You see it's about the same size as the yellow zone, which is always sized to usage over the lead time. And in the top case, 227%, like a 10-fold difference between the bottom and the top there. How can this be? Statistics says they should all have the same result, all need the same setting. Now, I'm a music fan, right? Shazam. Everybody got Shazam on their phone? right? Don't know the name of the song, you press the button. Doesn't matter what part of the song is playing, it takes an analog waveform out of the air, digitizes it, matches it to a library, and within seconds comes back with the answer. This artist, this album, bada, bada, bada. Amazing. How can that be? We started looking at the demand patterns of the items, and we noticed they don't look the same at all, right? Statistics kind of averages it all out, but it's not really reflective of what the real waveform actually looks like. Does that make sense? The other thing we noticed is that, something else is going on here. The one at the bottom has a big fat MOQ, minimum order quantity, right? It's actually probably 4 to 5 times the usage over the part lead time, right? So in DDMRP terms, the average inventory is all of your red plus half of your green. Well, if I have a big fat green zone, that's going to be a big number and it's going to pull up my average inventory and I don't need as much safety coverage there, right? So you see we're only down at 23% of usage and we get 100% service on this item. You also notice that this one has a slightly longer lead time. When this demand pulse, or this is the net flow, the planning line goes up to top of green, I order from top of yellow, order to top of green. The supply arrives the lead time later, right? You can see that that gap here is smaller than this gap, which means that the one at the bottom has a longer lead time, right? So that's got something to do with it. And then you look at the top one, it has a very, very short gap between the planning line and when the inventory arrives for that order recommendation. So this one has a very short lead time, has the smallest green zone setting of all 3 of the examples as a percentage of usage over the lead time. So it really tuned us into the idea that you have to take this holistic approach, right? Because if you don't, you're not going to get the right recommendation. Questions on this? Does this make sense, kind of the concept that I'm trying to communicate? We're all on board? Okay. Say Shazam. But this is really kind of where we start to look at how new technologies can help us. Pattern recognition became kind of the inspiration for what we were trying to do. And we started down the journey of figuring out how to make that happen. So Danny, kind of explain what we did.
Am I on?
Yep.
All right. So yeah, Autopilot kind of bore out of all these ideas that he's been talking about. And our goal with Autopilot was to make the lives of planners and users easier. Like he said, the smart buffer profiler, stepping through that thing, just so many questions about how do we set this up, you know, not just from our customers, but even our partners when they're going through and looking at a prospect's data, you know, like trying to go find the exact right buffer profile settings to make, you know, those results show that DDMRP can produce results that look good. And it took a lot of work and a lot of knowledge, as well as just a lot of, you know, trial and error, you know, bump that safety percentage up a little bit, you know, bump that lead time factor down just a little bit. So our goal was to eliminate that step. And we hope to do it by, a big thing that you're going to see in the demo is by including illustrations like the ones you just saw. You should be able to quickly see that, okay, the system has generated a setting for me that if I ran a simulation today over my historical demand, I can see that that setting that it generated produced the result I'm expecting. So does that make sense to everyone? We'll see that here in a minute. These are some of our priorities, kind of what we covered here. Coming up with better buffer settings and ease the onboarding process of setting those buffer settings to parts, quickly accepting them, applying them, and then over time, it will continue to maintain those settings for you. We did this through a partnership with a customer advisory board, thanks to Greif, Coca-Cola Beverages, and Aptiv. They have all been kind of working with us, testing our demos and testing our prototypes to see if this process has been very iterative. And along the way, we've you know, communicated with them in terms of like what the workflow should look like. Are the results they're seeing in line with what they would expect? There's been a number of, you know, different parts that kind of fall through the cracks. And they've helped us identify those and figure out, okay, what should those parts look like? Should those parts be getting settings? Perhaps they are parts with data exceptions that we can't process. It's that idea of bad data in. We don't want to put bad data in and get bad data out. So thank you very much to all of them. So the 3 phases of autopilot development are, we kind of established this a long time ago, our setup, approve, and it got cut off, but this last one here is adapt. So we have been focusing on this setup phase, just looking at your demand histories and trying to come up with the settings based on that. Going forward, we hope to continue to kind of improve this process by analyzing data from the part histories and ultimately using your part forecast going forward to adapt to potential changes that are coming in the future. Prototype period. Quick, you might have done this earlier. I missed it. Raise of hands. Who was here last year? Oh, pretty good contingent. How many of you happen to remember the prototype we did last year where we did a demo in it? Okay, a couple hands there. So yeah, we did a prototype last year we did it year before last year, really building up to the conference last year. And that was done completely separate outside of Intuiflow. It was written in Python. It was very much a prototype of our working idea in theory behind this. And that's kind of what we demonstrated to you guys. Let's see. So at the time that was essentially coming up with these buffer profile settings, we were seeing a lot of inconsistent results at the time. Oh, sorry. I forgot to mention at the top, the year before last year, we actually did clustering methods, which was essentially trying to take those demand patterns and group them into groups of demand patterns that were similar. But we found that much like buffer profiles, once you start trying to group things, you're going to start to see some inconsistent results because some things might be closer to the center of a group, but some things will be further away. So for instance, you might have a part, let's take the smart buffer profile example of, you're looking at a COV variation range from 0 to 50. The part that has 0 variation is going to be very different from the part that has 50 variation. And the stuff in the middle at 25 variation, everything might look perfect for. When we did the clustering, we saw that same thing. When you took demand patterns and put them together, stuff on the fringes were still not getting the results that we expected. So we shifted that and we moved to item level settings. And this is kind of what Eric was talking about. There's the factor of the demand series and the shape of that demand series, the lead time, and your MOQ or order cycle settings. Those are the 3 factors that really feed into what kind of result you're going to get for each part. And so we shifted into, okay, for every single part, you can think of every single part based on those 3 factors, almost makes like a little fingerprint, a very unique set of settings that needs a very unique result. And that was the prototype from last year, which we demonstrated. Since that prototype period from last year, we have identified a lot of areas for further improvement. And mainly what we've done at this point, we took that prototype and we've built it into Intuiflow. So what you're going to see today is the prototype from last year built inside of Intuiflow, where you can run it and see the results yourself. We moved it inside Intuiflow because we realized we needed to pick up all of your custom settings and everything, all the work you guys have done inside Intuiflow, utilizing planning calendars and exclusion dates and all of your system settings. We needed all of that in our prototype, and we were like, wait a minute, why rebuild all of that into our prototype? It's time to move it into the product, and where we can pick all of that up immediately, where you guys have input all that data. So these are some key development actions we've done in the last year since that last prototype. We began with data exceptions because the first part of the process we thought was that we can prevent you from putting bad data in by implementing a feature called data exceptions. So now when you import your data, immediately if some properties are recognized as autopilot isn't going to be able to do anything with this, they will fall into the data exception category. You can still put that data in and use Intuiflow as you regularly would, but autopilot will not be able to process those parts until those exceptions are cleared. We adopted the S&OP simulation logic. Last year, the prototype was running on a slightly different version of simulation logic. And you all are familiar with the S&OP logic, so it made sense to just reuse that same engine to drive autopilot. We developed autopilot workbench functionality, which I'm sure you all are familiar with the save views in the workbench. Now, when you're viewing autopilot, you'll see here in the demo, you can quickly save your views based on part type. You can group, you can organize columns every which way you want and save them so that you can go back and review stuff in the same manner. And we've continued testing with CAB clients. And with that,
Yeah.
I think I'll give it back to Eric for.
So one thing I wanted to thanks, Danny. Go back a chart. At the time too, we had looked at a couple different algorithms for the min-max concept. One was kind of for the lower service level target. One was a high one. We found that we were overcomplicating it. We didn't really need two different techniques for min-max. And so we went and changed into one that you'll see here in a moment. We also, a big thing we realized, at the time we were inheriting the item attributes. So if it had a forecasted rate of usage, FDU, setting on the item, we would utilize a forward-looking view of the demand history to generate the red zone factor. Well, that's like a wind-dated result in my mind, right? Where you're cheating. You know perfectly what the demand is going to be, and that's not reality. And the other thing we saw was that forecasts as a technique tend to not have anywhere near the level of real variation in them that actual demand history will have, right? So that was a big change. And it's when you see the results here, you're going to start to maybe raise some questions about that. But that piece of it alone, I think, was a step towards really making sure we've got the right setting. If there is true volatility in that demand, we want to make sure we're able to cover for it, and we want to draw a picture for you so that the user can see actual proof as to why. We don't want a black box where it just says trust the system, because if they can't see a confirmation of it in some fashion, it's not going to give them the results that they're looking for. And then two, in generating the results, we went through a number of iterations on the algorithms for that. Because if you start a simulation, it has to start on day one somewhere with a certain amount of inventory, certain amount of open supply, certain amount of demand or whatever. And if it has a long lead time, that pump won't actually be primed and set up to run the way it normally would for at least one lead time cycle before you can actually say those results are credible. So we went through a number of evaluations of different algorithms that we could use for both the initialization of the simulation as well as the period through which we would analyze the results. And I'll show you some of this when we get into the demo. Questions so far? All right. See how well I can navigate here. Here we go. You're now in Intuiflow. Okay? I'll try zooming in just a touch because it's a little. Okay. Data exceptions, let's go there first. So the data exceptions process here, oh, I got this thing in my way. Anyway, the idea here is that there are a number of conditions which we would consider data exceptions. And you can see the categories here down below the upper level. Demand did not meet the threshold. So there's a setting in the autopilot, and I'll show you here in a minute, that says here's the minimum number of pulses of demand, days of demand in the year. Below that, we don't think it makes any sense to have an inventory position or hold stock in it because it's probably too problematic to hold that inventory. So if the item has not enough demand pulses in the year, it will opt out. No materials cost. I can't show you a resulting inventory value change without the material cost. No lead time. I know it doesn't have any of these issues, so no worries. MOQ exceeds order interval day. This means that if I'm on some kind of a planning calendar, like I've got an order interval of every week we're going to order because we set that 7-day kind of order cycle value. If my MOQ is a lot greater than that, then I'm not really going to be planning on that horizon, and maybe I should look at changing those settings to ensure I get good results. Expired part pattern. We see demand, 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 then there's no demand. Looks like that part's been phased out. So let's set that one aside for somebody to look at. Maybe that's just, it's got a very period-specific demand, and so we should recognize that and plan a material strategy for that. Similarly, you've got new part demand. No demand, then all of a sudden demand the last couple months, right? And for us to generate good results for that, we should take a look at that specific scenario and make sure we're accommodating it correctly. Missing order cycle or minimum order quantity. This kind of reflects that there's some data maintenance. Like if you have a minimum order quantity of 1, the simulation will try to generate an order every day, typically if it's got a lot of demand. And that's not typically the way you're going to want to operate that part, right? You're going to want to order maybe once a week, maybe once every other day, something different than ordering every day like that. No demand at all, kind of goes with that one, but we can't simulate that. MLQ greater than the total demand. So we're typically doing 52-week simulations. If the MOQ is larger than a year's worth of consumption, maybe you ought to check that MOQ value because that looks odd, right? I'm sure it exists. We've seen it happen many, many times. Clients are holding 1,000 days worth of supply on a given part because the only way they could buy it was to sign up for a big MOQ from the vendor. And unfortunately, they get stuck with all of that inventory. And then the final one, outliers. Outliers would be demand pulses that based on our algorithms look suspicious, because they are a big inflection point away from what the normal demand would be. And so this exception report then highlights those, and then you can go investigate and remediate these actions so that you can get more parts to go through the autopilot functionality. A few of these are critical exceptions. We're not going to do anything until you get it fixed. A few of them, it'll continue to do the results to help you get that output, okay? Data exceptions. This philosophy of get these cleaned up first makes sense to y'all? Yeah? I see some heads nodding. Maybe some people are falling asleep. I don't know, but anyway. All right, so let's go to autopilot. So this is a job that will run in the background. It's a fairly compute-intensive job. And I'm going to go to a save view here for my 6-pack items. This is kind of a bottling example. There's a setting in the system that you go back and you trigger the autopilot run based on your user preferences that have been set up. So I'm just doing the bottler location, all the SKUs in that location. And it will then generate these results. And it brings back the results in this autopilot workbench screen. You can see here the status that these are all ready. They've got good results and they're valid to go forward. It shows the proposed method. Buffered would be a DDMRP defined buffer. Min-max would be a min-max defined buffer using our proprietary algorithms for generating that min-max, right? They're not based on those statistical formulas. They're based on the other algorithms we base. Over here to the right, you'll see it shows the current inventory as well as the current target inventory. And then based on this recommended method, it will show you a comparison between the current inventory and what your autopilot inventory would be, right? So we're seeing variances between these two items. Up here, you'll see the summary value. So in this case, there were 11 items in this selection. They have a total inventory value of $3 million. Autopilot is recommending we can get down to $1,124,000, which is almost a $2 million reduction. We hit 100% service level, okay? And 3 of the parts are going to be on a DDMRP size buffer, and 8 of the 11 parts will be on a min-max. None of the parts went down the non-buffered route. And there are a number of other columns in here. I'm going to just pick the column selector here and kind of give you an idea. But you can see here that you can personalize this view. You can see a number of the min-max settings here, right? It'll show you all the results for these 3 different thresholds. Now, where did those come from? Well, that's where we go into settings. Yep.
I can't remember if you said if it is considering the MOQ.
Yeah.
Okay.
Yeah.
And then I remember that you're looking at essentially MPI and POL for items. New product introduction.
Yep.
But is it looking at seasonal demand?
Yes, seasonal items will show up in here. Yep, yep, absolutely. And we'll talk a little bit about what we're learning about the results we're seeing from, thanks, Chrome, from those different results. Let's go to site admin, then I'm going to come back here and we'll go into the processing area. And this is where you set up the basic settings for autopilot. So we have to set some boundaries. So we have an ABC concept, and it's based on the number of demand pulses over the analysis horizon. Demand pulse is a day of demand. There could have been several demands on that day, but it's the total of demand on that day, right? So if I have 20 pulses in a 26-week horizon, that would mean there were 20 days where we had actual demand for this item or consumption. It could be consumption, meaning it's issued to the floor if it's a buy item. It could be consumption as a finished good being shipped out to a customer in the market or transferred to a distribution center as part of its journey, out to the market. In this case, we set 100% service level for anything with 30 pulses or greater, 95% service level for anything with 20 pulses or greater, and 10 pulses was our minimum threshold, and 90% service. By service, we mean it's the number of days of availability. It's not service in a way I had this order and I served it on time. It's looking at pure stock availability. That's the definition that we're using in our service level dimensions. Yeah, a lot of times companies will measure their service level, meaning how well did they ship to the actual orders they had. We're looking at it as how many days did we have stock outs, right? So if I have 100% service, that meant I had inventory every day for the whole year, right? And in essence, I can service every order that came in. And it also assumes in the simulations that you're servicing the order on the day the order arrives. You have no forward visibility here at all, right? So it's taking a very, very, very conservative view of configuring that stock position to make sure that you can be agile, right? To respond to whatever demands come in. We set an upper threshold level here, 500%. That means that you'll never let the red zone be more than 5 times your usage over the lead time. We know that if we set this higher, you're going to get some ridiculous stocking recommendations where you're covering so much risk in your demand that you really probably would be better to make that item make or buy to order, right? So this is, again, you got to set boundaries here about where do you apply certain technique and method and where don't you, right? Some of these items should be bought to order, make to order, and let's not overlook that's a valid strategy. If you're on the left side of that spectrum chart that we showed earlier, you don't want to stuff a square peg into a round hole and force it to be on a certain pattern or method that doesn't make sense. If you're ultra conservative, you can add another safety element. So, we're going to try to get you to the service level you want with the least amount of inventory. But if that's flying a little too close to the ground at certain points in the year, you can put an extra setting of additional cushion in there. We don't think it's really going to be necessary for most clients, but it's there if you feel maybe in an initial implementation, you might favor that just to give you a little bit more flexibility and again, build that confidence in the system. This is simulation look back weeks and how far to simulate. So it says start the simulation X number of weeks back and then go for however many weeks. We've done a full year in both of those. The new part definition is demand within the last 13 weeks. The expired part definition is demand only in the first 13 weeks. And so these settings are configurable that you can set them at different locations a little bit differently. Gives you some flexibility. You would typically be a power user that's going to be responsible for configuring these kind of settings and allow them to take root across the system. Any questions on that? Yes.
Are you able to run autopilot over a select number of part numbers or part numbers rather than the full?
Yes, and I'll show you here on the workbench of the autopilot. You'll get recommendations for a lot of items, but you may only want to filter it down to certain product categories or certain planner codes and things like that and utilize it we chose to let the job run for as many parts as we need to and then cull it down to the ones we want to work on by using that workbench because there's an ability to set the enablement.
And I just wanted to add a quick note that the 500% red zone factor upper limit, that red zone factor, all of you familiar with DDMRP, think of the red zone base and red zone safety. For autopilot, we really tried to simplify it down to one number. It is, we call it, and I just called it a red zone factor, and it is just that straight multiple of the yellow zone. It just made going forward the math a lot easier. We found to, when coming up with a solution, it was easier to just solve for one value than trying to manipulate two of them accordingly.
Yep. So now you've been saying, well, where's this magic illustration of what we're getting? So when we click on the item, we can bring up the autopilot. And this is going to show you a graphic that says, here's the inventory levels between the two methods. The yellow is the buffered method. The blue is the min-max. And what to achieve the various service level points, 90, 95, and 100, what the average inventory requirement was to get there. And then when we click on the simulations tab, you actually see the actual results. The top bar here is the actual demand pattern that this item is experiencing. You can see it's pretty heavy running demand pretty much every day. Got some pretty heavy concentrations of demand in a couple spots. You see a comparison here of the average inventory value in the buffered scenario was 35,000. In the min-max scenario was 30,000. So it got to the target of 100% service with slightly less inventory than the DDMRP buffer. You notice now it's after it refreshes the screen, it sets both graphs to the same scaling, right? So you get a much more genuine comparison of the results. One thing you would see here is you notice how the buffer is increasing in size, and that's because the rate of demand is increasing as we go through the year, right? So even on that main page, we showed that more of the items were getting min-max settings. Doesn't necessarily mean that that's the right way to go, because we know that especially with items with forward-looking variation in their demand, you may want to be following a dynamic buffer, which would be more the DDMRP configuration. But it's visual proof that, hey, given your demand pattern, if we go this route, we carry $35,000 worth of inventory. This route will give us 30,000. We never have a stock out, right? And this visual proof, I think, from our CAB clients was a key part of the whole story, is that once people see this enough and they gain confidence in what's going on behind the scenes here, they're going to have more confidence that the system is doing the right job. We can come down and look at the two other service level situations. Here, the buffer was a little bit better, achieving 95.2 with a lower level of inventory. And then at the C level, which was the 90% service level, then the min-max seemed to be a little bit more favorable in that regard. Questions on that? What do you think about the visual element here? Does this provide a reinforcement? Now, I know not everybody's going to look at every item, so that's not the point. It would be your key items that are most problematic for you are the ones you're typically going to investigate. But does that, we think it gives you visual confirmation, but very interested in your feedback on that. Yes? There's a thumbs up. I like that. Okay, and so you can then see, we'll go close this down. Oh, by the way, if you wanted to rerun an item at an individual level, let's say you change some settings, you can go ahead and click the rerun button, and it will respect that and regenerate the results for you. In this case, I've used these filters here. We can set up different views with different filters. In this case, I chose to select a material type equal to 6-pack 2 liters. I can do that on vendors. I can do that on certain value stream designations. I mean, we've got so many data elements in the system now, and the filter arguments are pretty pervasive. Well, here you could see, you can add multiple categories, user-defined fields, all sorts of different elements as a way of getting to a better place. And then simply what you do when you want to save a given view that you've created is you click this dialog, give it a name, and it will respect all of the settings that you've created there. So we now use this as our simulation tool for new prospects. We'll take their data, put it right into the software, not in Excel. We got rid of one worksheet. Yeah, but I loved it. The hours I spent sweating over that thing, my God. But it's respecting all of our calendars. It's all of the dimensions that you can think of. We have these planning calendars that are used in automotive, especially where you got 3 days a week that you can generate orders on and other elements like that. But it's a much more valid way of showing the client the way the solution is going to work, because now we've got their data in our platform. When we do a demo, we're going to show them what the autopilot results are. We've got a number of clients that Tim and I are working on in India that are really, really interested, and they're seeing something different. By the way, SAP has in their S/4HANA release, if you dare to go there, you know, some DDMRP functionality. They have nothing like this capability. In fact, we don't know of anybody else that's really done something in this manner. But it helps illustrate the functionality, and inevitably, we learn things about their data. We learn things about the way their items behave, things like that, and it starts to gain credibility in terms of what the demonstration is showing and how the functionality works. Questions on that? John?
So do your buffers, your inventory net planning instead of having a lead time category?
It's going to be a setting for that item. Technically, it's 6 new techniques, but they're all, each of those 6 techniques will result in one setting for you, right? It's not going to be done in this grouping. We did that clustering initially that Danny mentioned, where we were looking for patterns because we wanted to stay consistent with the DDMRP logic of we're going to group by variation ranges and generate better settings that way. And what we found is we would repeat these runs time and again, and we were getting results all over the place. It wasn't working the way we wanted it to. It was better than, if we used those settings that we were getting, it would still get better results for the client that we were evaluating. But it wasn't nearly as, it didn't have the integrity that we felt this would be able to get us to.
I think following up on that. So when you enable a part for autopilot, that recommended column, if a part is buffered, it's going to set its inventory method to replenished. It's going to assign it technically a buffer profile of AP for autopilot. That profile is specifically targeted for order cycle and min-max methods, and it has essentially no green zone lead time. But other than that, it's a standard buffer profile. So it'll set the inventory method, set the buffer profile, and it'll turn on autopilot for the part, basically telling it, instead of getting your red zone, green zone, yellow zone settings from a buffer profile, get it from the results from autopilot. And if it is recommending a min-max and you enable it, it will turn the replenishment method to min-max.
We're going to get there in a second. Yeah, thanks.
So for the parts that are not autopilot, are we still using?
You can still
You
continue
can still
to
run the
use-
Smart Buffer Profiler and get your results that way. Absolutely.
Good question.
In fact, there's a feature in the Smart Buffer Profiler called the data analysis, where you set a horizon and it'll show you all the stats in terms of COV, largest demand pulse, how many pulses there were. You set a setting in there for how many weeks you want to evaluate. That same setting is the one that the autopilot's using. So there's still some affinity. We're not going to take SBP away anytime soon, Doug. We want to phase this in. We know that there's further improvements, which we'll talk about in a minute. But it's, like we say, a big step forward in terms of giving you actual results that make sense, right?
One last note while we're here. We also added the ability to override autopilot.
Which
So
is,
you might like the results coming back from it, but let's say you have a part that it has only 12 demand pulses, so it fell into the C category. Autopilot's like, you only need 90% service level on this. And you're like, no, I need that thing all the time.
Yep.
You can we implemented overrides to where you can still select that A service level for that part and enable autopilot, and it will just always use the A setting coming back from autopilot.
Yeah, because we have aftermarket parts that.
Yeah, you can't stock out.
Like 4 times a year.
Right.
But they're 2,000% margin. Right?
Yeah.
So
Exactly. Yeah.
Yeah.
there's a
Right.
lot of those stuff.
Yeah, if you're in aircraft maintenance, you want engines around because a plane on the ground is not making anybody any money, right?
And does it analyze the ball structure? Or?
We'll talk about that in a few minutes. We've done decoupling analysis, Doug. We have a prototype of how that would work. You're going to get a chance to vote on this in a few minutes when we go to the WOOC lab. You could see I did an override here on this item, 150971. And I've opened up the part simulation capability in SNOP per Rita's request. I was a step ahead of her, actually. Go away. Go away. There we go. Here we go. We're going to pick up this item. Now, we're going to run and turn this off. We're going to do a historical simulation based on the autopilot recommendation, and we're going to see what it generated. And you see the, yeah. There we go. So this generates the min-max result. And this is using the demand history. So this is basically looking at the recommendation we got against that demand history, and it should confirm the exact same view you saw in the initial graph in the autopilot, right? Now, what if I want to evaluate this against a forward-looking rate of demand? I'm going to turn off the use demand histories. Now I'm going to run it against a forward simulation. And this item happens to have a pretty significant increase in its rate of demand. And so what do you see happening here? Yeah, it's stocking out because the min-max is inadequate. It's not rescaling as that demand increases, right? So we have the option here, and we should be able to see a result if I did this right, of evaluating the AP setting for this part going forward. And you'll see a very different size buffer and a better result. There's still a shortage of inventory in the beginning, and that's why you see the initialization is a little low. But we're able to get better service level across the year based on the dynamic buffer. So we'll talk about this in a minute, but we know that there are some further improvements we can make with the autopilot recommendations. In most data sets, we're seeing that the min-max is slightly ahead of the dynamic buffering. We got some theories behind why that is, and we're still evaluating that. But we know that a static buffer in some cases just isn't going to work because you've got those seasonal patterns and things like that. And what else? So the part simulation is kind of that idea of testing whether your model is going to give you the right results, right? We can do these in aggregate by running all the items that have been assigned and checking each of their inventory values. We can go through the S&OP module and look at certain categories of items for that, and we can evaluate their performance. In fact, the way we might do that is we'll go to the projected buffer trend and look at those 6-pack 2-liter items and see what their results were here. We'll go to the material type, check the 6-pack 2 liters. We'll expand our projection view out to the first 12 months, and we'll get a view of what our service level is. We're hitting 99.1%. Our average inventory is 3641. Our current inventory is 3201, but we would have been having more stockouts given these demand patterns, and we're getting a better result. And you can see we're very much in line with kind of what the target inventory would be. So questions on this? Just checking our time.
I have a quick,
Yeah.
not really related to what's on the screen now, but we were talking about saving views and how
Yep.
you can personalize which columns you want to see.
Yep.
Is that a global save? If you do it by profile, if you have like a role
Yeah.
profile, or does each person?
They can be set up individually. You can share the definitions with other users and get replication that way through it. Mhm. And you can move the columns around. You can lock certain ones to the left and all sorts of different sort options. Quite flexible to make it tailored to what the user wants. So now if I'm on the buying side of the team and I've got 7 primary vendors, I can have specific views for each of those vendors, drill through them. You'll see we've got load optimization functionality, all sorts of other things that we've added to the material planning side that you'll be able to utilize. And you'll see a lot of that in the next session after Rita's. Okay, let's go back and wrap up here. We got to do our woo clap here and see how this goes. All right, back to the presentation. Why am I not getting there? Oh, I'm picking the wrong icon. Here we go. All right. Demo. Just an observation. Typically, the dynamic buffering is better when you got some seasonal patterns. There was a question about that earlier. The static buffer tends to be better when you've got what we would call lumpy demand. right? Where it's got spurts of usage and not. And you know, the other thing about the min-max method here, there's a lot of companies out there who've not really gotten down the DDMRP path, who think in min-max terms. So in a lot of ways, we think this helps give us an appealing offer to those clients that maybe aren't really on the DDMRP train as yet. Okay, these are things that we're thinking about. Okay, get your cell phones out, by the way. Right, in a minute, we're going to show you a QR code we need you to access. Forecasted usage versus the autopilot settings. What about adding another computational cycle that says after we generate the autopilot results, we validate them against your forecast? Because in that one case, it would have flipped the switch from min-max to buffer, right? Demand usage horizon. This is an interesting one. I'm going to go forward here for a couple seconds. We have done a lot of research on this as well, because that was one of the settings, if you remember, back in the DDMRP method. What is your daily usage horizon? Well, I would continue after saying, doing so many simulations, tell clients, longer tends to be better. Not always, but tends to be. This is looking at a set of different service level objectives, how much inventory you needed based on a different ADU horizon. You can see here, it gets better with a longer horizon. The more stable you make your dynamic buffer, the more reliable it becomes. This is another one with, this is the demand pattern we're analyzing. You can say the 100% service level went down dramatically based on a longer and longer usage horizon. We also found that there's things you definitely don't want to do. This has 180 days between seasonal peaks. Do not set your setting at half that cycle, because you will always be halfway out of phase. So there was a lot of debate in the DDMRP literature about what these usage horizons. We know this is an area that we can bring more of our autopilot thinking to, so we expect that will be one of the options that you'll get to vote on here. Supply archive, lead time variance. This is a big one, especially given what we've been through with COVID and the like, is that we know there are situations that are aggravating lead times. People got behind on back orders, so they had to extend their lead times out further into the future. That then created problems for you and your clients. Should we add some functionality around measuring that? There's some data elements that we're going to need to add to make this come to life, but it's an interesting one. Bill of material decoupling points. We know if we hold stock at certain places in our bill of material, we can compress our decoupled lead time for the end item. Some companies have very, very complex bills. And we know that we have the logic already prototyped that would allow you to decouple or disengage the buffering for items that aren't helping compress your lead time. So in those cases, just order them when you need them, because otherwise you're committing to inventory that you're not getting any incremental value from.
A good example of this is right now, Smart Buffer Profiler and Autopilot. They're going to choose your buffering points simply based on the number of demand pulses. Let's just take Smart Buffer Profiler. If you say everything over 10 demand pulses, I want it buffered. You might have every level, the bottom of multiple bills of materials where every component has over 10 demand pulses, and it's going to say buffer all of those. A handful of those probably have a shorter lead time than the rest, and you're not, you can turn those off without affecting your finished goods at all. As long as you have the long lead times buffered, you can turn those off and immediately have savings without affecting anything else in the system. Now, granted, there will be times when you probably want to hold them anyway, but we do have a prototype that can go through and find that logic. And it obviously can't just look at one bill of materials. It has to look at the shared components everywhere it is in any bill of material and make sure that turning it off doesn't affect the system as a whole.
Yeah. And the other side of that story is not every candidate can be a buffering point. If you've got, if you're at Freshmark, you're making hams and stuff like that, there may look to be some intermediate points, but you can't stop that production flow. So you have to kind of discard that. So that's some of the other things that you have to be thinking about on that front. And then the last one is this part history analysis. That goes back to that chart that Danny showed. One was the setup phase. The next is the improve phase, where now we can couple in, and this is where the ChatGPT kind of ideas and others may be value. We can analyze how you've actually been performing for the past year and compare that to what Autopilot's recommending and make suggestions on why is this the case? Why is Planner Joe always over top of green, right? Buying double to stay out of trouble. Maybe there's some things we can correct there. Maybe we're over manipulating orders just because that's what planners think they're supposed to do, is change what the system recommends. There's all sorts of stories like that out there to deal with. Okay, so Kevin, let's do it. Where's the QR code? All right, scan that on your phone. And open up the app. And we're going to ask you to rank order those 5 items we just showed you in terms of your preference, right? Such a high-tech company, huh? Answers coming in. Good. A check mark on. Interesting. I know who or teed that one up. We have any more, Kevin, coming in? Oh, here, I see down here we've got, can we get to see the aggregate results, Kevin? Not just. Okay. Still another 10 to go. Yeah, right. Everybody got their stuff in, or need a couple minutes more? Oh, really? Yeah. Hopefully we're not asking for last 4 digits of your social security number or anything like that. Oh, okay. All right. Can we show the summary results? Or is this the only view we have? Okay. Okay. So the top 3 would go left to right, Kevin? Okay. Interesting. Interesting. So we met internally, and we were leaning on the forecasted daily usage. That shows up in the first group, is in second place, first place in the second group, and third place in the third group. So that's pretty consistent. Part history analysis. This is the idea that we can take your actual usage patterns and learn from them, and then convert them into improving the recommendations, either in the buffer settings or other ways back to help coach your team and get you better results. That showed up as kind of the top of the list here on the, this was a column that had the most common set of responses. Demand usage horizon, yeah, I think there's a lot of leverage we can get out of that. We've seen that, and it kind of goes back to what we just shared with you from that initial research we did. The decoupling points one kind of falls down a little bit. Not every client is going to get as much leverage. Certain cases, I think there's a business for that, like at Coke Enterprises, you've got really these complex manufactured bills. There may be good opportunities within that, things that you don't need to be buffering. So it's just another good illustration there. And then the supply archive, this would be being able to actually see from order till receipt what that time horizon was. And look at the amount of variation you have. Obviously, if you expedite an order, it's going to come in 5 days, whereas a normal lead time may be 90 days, and that can add distortion. So you got to be a little bit careful about all of that. But we're going to summarize these results. We'll share them with everybody afterwards, so you've got that to go with. Okay? They're the next phase of autopilot development. Yeah, so we have a meeting on autopilot every day. Okay, so am I done now? We have 3 more questions. Oh, sorry about that. 2 more. Okay, these were yes, no questions. These should go a little quicker. Do I click? Up, up. Okay. Improved settings will lead to greater use of auto approve. If that isn't faith in the system, I don't know what is, right? So if we get the settings right, and we obviously have to demonstrate that and convince your users, will we get more auto approval? The polls are heavily in favor. That's good. Huh? Yeah. We're going to come back and audit your responses. Okay. We have another question, Kevin? Does it matter whether we are on a dynamic DDMRP buffer or recommending a min-max? Some in our circles would say yes, this is relevance. I don't think so personally. I think as long as we're giving you a setting that you agree with, who cares what we call it, right? Wow. Wow. The early precincts are in and they are weighing heavily on it doesn't matter. It just doesn't matter. Okay, do we have one more question?
Yes. The open-ended question.
Okay. What other areas? Now this would be, we've obviously shown you 5 suggestions. This is free-form text, just put in your thoughts. And we'll take a summary of those. Autopilot for scheduling. Yeah, I wonder who will be asking about that. ABC classification for revenue. I like that. Autopilot will work for distribution out of the box, so we've already got that functionality. Settings analysis. Dude, sweet. I love it. All right. Well, thank you for this. We're going to try to wrap up here. Now, great answer. So we're trying to get that user confidence. That is foundational to everything we're trying to do here. We think we're on the right path. We've had a lot of client feedback. Your answers today kind of reinforce what their comments have been. We know there's limitations in the methods that are out there in the market today. The more visual proof, I think, the more convincing, right? Pictures tell, 1,000 words or whatever. And then obviously we can phase these in per Rita's question. You can take them segments of your items at a time. It's been available since earlier this year and will be obviously available in all future releases.